In this video, we're going to look at the laws of exponents for a negative exponent. So what to do when we have a negative exponent in the problem. The reason we have the negative exponent rule is we want our final result or our final answer to not have a negative exponent in the answer. So we use this rule to help us write it so we can change it from a negative exponent to a positive exponent. So our rule for this is if we have a base to a negative exponent, it equals the reciprocal. So a negative exponent is referring to a reciprocal. So what we do is we can think of this as over 1. We flip it to its reciprocal, so 1 ends up on top. And then the 4 squared, or 4 to the second power, now becomes a positive exponent. So it takes a negative exponent and gives us a result that no longer has a negative exponent. So we're going to look at how we can do this with a couple different situations. So our first is if we have, I'm going to leave this here so we can kind of reference it. What do we do when we have a numerical base? So I have a power with a numerical base, so a number for the base to a negative exponent. Well, in keeping with what we see here, so 4 to the negative 2 became 1 over 4 to the positive 2. I can think of this as 5 to the negative second power over 1. I can flip it to its reciprocal, but I'm going to make that exponent positive. I'm going to keep it a 2 instead of a negative 2. So this is 1 divided by 5 squared, which we could also think of as 1 divided by 5 squared, which is 25. So either one of these would be an acceptable answer for what is 5 to the negative second power. If we apply our rule again here, 2 to the negative third, I flip it to its reciprocal and give it a positive 3 exponent, which I could take one step further, 1 over 2 times 2 times 2, which is 8. So 1/8. In this next one, I'm not going to write it over 1. I'm just going to apply what the rule tells us to do. So I'm going to write, instead of 1 to the negative 2, I'm going to go 1 over 6 to the positive 2 power, or 1/36. Or, yeah, 1/36. So 1 divided by 36. This is applying the rule, these first answers. This is taking it one step further and simplifying from the exponent, which we can do when we have a numerical base. In our last problem, 1 over 10 to the power of 5, which we could also say is 1 over 100,000. All right, let's look at what do we do when we have variable bases. Everything stays the same. The rule doesn't change because I have a negative exponent, so I'm going to follow the rule for negative exponents. I can't evaluate much further than applying the rule because I don't have a numerical base. So in this case, 1 goes on top. X to the positive 8 moves to the bottom. M to the negative 6th becomes 1 over M to the positive 6. Now C is a little different. I'm actually going to write this. So I'm gonna write this again. It's 6 times K to the negative third. Well, 6, I can't do anything with the 6 because it doesn't have a negative exponent. So the rule wouldn't apply to the 6. The rule will apply to my K to the negative third power. So I'm simply going to rewrite this as 1 over K to the positive third power. Now, if I want to multiply 6 times 1 over K to the third, when I multiply fractions, I multiply numerators and I multiply denominators. So I can rewrite 6 as 6 over 1, and then it's 6 times 1, which gives me 6. And then underneath, 1 times K to the third is K to the third. What I've done is because if I want to take kind of a shortcut to this, the negative 3 exponent is only on the k, which means only our rule applies to that power. So what's essentially happening is I'm taking this k to the negative 3, I'm writing it to the bottom, or bringing it to the bottom, to the denominator, k to the positive 3, and I'm just leaving that 6 up top. Now, how does that change? In the previous one, we were writing, kind of all our other ones, we were putting 1 on top as a kind of a placeholder. Well, in C, we don't need a placeholder. That 6 is our placeholder. So that 6 is going to stay on top. So if we wanted to kind of go the short route in the next one, negative 7 times m to the negative 9. This negative 7 does not have the rule applied to it. The rule is only for negative exponents. So here, this part does get the rule. So like we did in the last one, I'm just going to move it underneath the negative 7, giving me a result of negative 7 on top, m to the positive 9 on the bottom. So I kind of took that shortcut. I didn't write all the steps. I just noticed that I could take the power with the negative exponent and move it underneath that first value. So negative 7 on top, I moved the m to the negative 9. It got the rule, which put it on the bottom. Let's do the same thing, simplify. So we're going to multiply, divide our powers, and then we're going to make sure we write with no negative exponents. So A is multiplication. Multiplication, I add my exponents. I'm going to put a 1 on here. I'm going to have this, I have the same base, so I get 3, and I'm going to add negative 5 plus 1, which is negative 4. Now I want to apply my negative rule, so I don't have a negative in my answer. So this is going to end up being 1 over 3 to the positive 4. 6 to the negative 7th times 6 to the negative 7th times 6 to the negative 2nd. I'm multiplying, so I add exponents. Negative 7 plus negative 2 is negative 9. I don't want a negative exponent, so I rewrite it as 1 over 6 to the 9th. Multiplying, add exponents. 7, negative 3 plus 6 is 3. I don't have a negative exponent, so that would be my final answer. All of these would be my final answer. In D, here I'm dividing. My division rule for exponents is to subtract the or for powers, I should say, is to subtract the exponents. So I keep my base. 7 minus 9 is negative 2. Here, I want to rewrite this so I no longer have my negative exponent. In E, again, we're dividing powers. Keep the base and keep those parentheses. We're on our base. 5 take away 9 is negative 4, which we'll go ahead and rewrite as negative 2 to the positive 4. F, we are dividing, so we're going to divide 10 and 5. 10 divided by 5 is 2. Then I look at my x powers. 3 minus 6 gives me x to the negative 3, which we would keep 2 on top and drop the x to the third on the bottom. G, we are multiplying, so we will multiply the 3 and the 10, giving us 30. And then x to the third times x to the fifth is x to the eighth. I have no negative exponents, so I do not go any further. H, multiplying again, so 7 times 2, 14. m to the negative third times m to the negative fifth. I add those exponents, giving me m to the negative eighth. Can't have that negative exponent, so I bring the m to the negative eighth to the bottom, leaving me with 14 on top and m to the positive 8 in the denominator. And our last one. Got a couple different rules here. First, what we're going to do is we're going to simplify the top, which is going to give me 5 to the first divided by 5 to the fourth. Now it's division, so I would subtract exponents, giving me 5 to the negative third. And then I'll apply my negative rule, 1 over 5 to the third. And that is how we can apply our negative exponent rule, so we can write our final answers with positive exponents instead of negative exponents.